Hello dear friends, welcome to Studio Anywhere. Today in this session you will get to know about the core structure of ETABS Basic, ETABS Advanced and Safe software. The structure of course is designed in such a way that a person shall have sufficient basic knowledge to analysis, design and detail the building. It includes the implementation of codal provisions to the software and interpretation of result. Module 1, which is ETABS Basic. ETABS is a finite element based software used for analysis and design of structures. Its graphical interface gives a 3D visualization of a structure. It's difficult to analyze and design a building with different gravity and lateral loading along with load combination manually. ETABS gives a flexibility to such time-consuming and tedious job on a click and in a frequent of second. The display output, reports, and schematic drawing allow user to understand and help to generate the GFC drawing. The module covers the elementary introduction with static analysis of building. Module 2, that is ETABS Advanced. Dynamic analysis of structure with P delta and structure with geometric irregularity in plan and elevation and modeling it with moment frame, structural wall with moment frame, structural wall with perimeter frame, structural wall with frame tube, etc. With principally achieving modal behavior, limiting story displacement, stop story drift, the stability checks, etc. and many more adhering to BIS standard provision to making building structures safe and stable, sustainable with minimum operation and maintenance cost, optimizing the consumption of rebar without compromising the overall irregularity in built structure and make the structural system efficient. Module 3, that is SAFE. SAFE is a tool used for designing concrete floor and foundation systems. From framing layout all the way through the detailed drawing production, SAFE integrates every aspect of engineering design process in one easy and intuitive environment. So let us talk about the course outline. ETABS Basic comprising of four different parts. First, that is introduction to ETABS. Second, that is modeling, and third is analysis, and fourth one is the design. In the introduction of ETABS, we'll talk about software algorithm, capabilities of software, strength and weakness of software, ETABS manual, sufficient of significance of menu button and icons, sample model and templates, hands-on software and sample templates. In the modeling part, geometry creation, modeling of in every RCC element, 2D import, 3D import, other import techniques, property assignment, loading, releases, diaphragm, the definition of different parameters, checking the model technique, modeling of steel and composite structure, and hands-on of all these things. During the analysis, we'll talk about static analysis, dynamic analysis, second order P delta analysis, sequential analysis, time history analysis, significance of every analysis and its uses, check of different lateral stability, deflection, soft story, story drift, torsion irregularity, mass irregularities, and stiffness irregularities. In the design section, we'll talk about column and beam designing with methodology and limitations, design of composite column, design of wall and slabs. In ETABS Advanced, we'll talk about the various complexities like geometrical, code-based, structural engineering, fundamental based complexities, different software modifiers that we have to use, the reason why using stiffness modifiers, complexity during modeling, and We'll talk about the intersection point and its significance. When it comes to analysis, different type of complexities in a project and how to deal with it efficiently, stiffness modifiers for various building element and their use, application along the codal provision, interpretation of norms for high-rise building analysis and design, gust factor analysis, wind tunnel analysis, high-rise committee norms, its structural significance and its optimization and reporting. Why nonlinear analysis is important to high-rise building, its performance and how to interpret the data and how to gives us different parameter. Modal analysis, its study the modal history and dynamic time history analysis, vibration analysis, energy versus virtual work diagrams, modeling of composite structure, the analysis and design part, torsion irregularities and orthogonal axis analysis and its application, soft storage checks and its applications to the various software. Again, by performing the advanced analysis, how to design column, beam, slab, shear wall, transfer slab, and brace element, a structural design optimizing after all this advanced analysis. Third module is SAFE. In the introductory part, the software algorithm, capability of software, strength and weaknesses of software, SAFE manual, significance of menu button and icon, and sample model and templates. In the modeling, we'll talk about the geometry generation, modeling through import methods, combined in complex foundation system, foundation, basement, and footing and flat slab, property assignment to the rigid zone of wall and ramp, usage of intersection point for the beams and column, property assignment for spring support, use of design strip, definition of post tension in beam, slab, tendon load and its losses, loading like dead, live, wind, earthquake, temperature, notional, live load reduction, releases, support, diaphragm, and checks on modeling technique. In the analysis part, process and technique, which consists of interaction between ETABS and SAFE, soil structure interaction, check on foundation system like deflection, which consists of two things: short-term deflection and long-term deflection, considering creep, crack width, punching shear one way, two way, reinforcement check, different settlement of foundation and its control, non-linear analysis by considering long-term creep, non-linear analysis for crack condition, analysis of flat slab, checks on foundation system and flat slab against lateral force, static and dynamic both ways, significance of each analysis and its uses using various code. The design consists of design of stirrups, design of slab based on finite element method, design of raft, pile, different design methodologies, design of punching shear reinforcement, flat slab with post tensioning, checks on post tensioning stresses, generating output and display of deformed geometry, detailing and reporting techniques, codes and software interaction by considering national and international codes.